Hello friends, in this video now we are going to start this is the very basic reaction and used so many times in laboratory also. So the name of the reaction is that esterification reaction. What is esterification reaction? Then in the name of that reaction, mechanism of reaction is hidden. So esterification means product is hidden. Esterification means there is the formation of ester from. Now let's see the starting material. What are the substrate for this reaction? So esterification reaction is as here acid in presence of alcohol in acid is reacted with alcohol in presence of acidic medium, which is reversible reaction. It will give OR dash plus water. Hydrolysis esterification. So this is the very simple reaction. Now let's see the mechanism of that reaction. How this is the formula. Here direct method. First we will see what is the direct method. If you see here, what is the formation of product? How it is formed that? Let's suppose here in acid plus any alcohol. So remove the water molecule only. OH from acid and H from alcohol, and make the bond of that oxygen and that carbon. OR dash. This is the direct method. Now let's come to the mechanism of that reaction. First, what is happening is that here acetic acid is there, acidic medium is also present. So what will happen? This is itself is acid and again acidic medium is there. Then what will be the form? This OH group will be protonated. So what will form? O, here H positive charge will come. Now this water becomes very good leaving group. This water will be leaves out, and what will be the intermediate? This will be the one of the intermediate formed in that reaction. So if you can ask me that, one doubt will become in your mind that why not alcohol will be protonated in acidic medium. Let protonate that alcohol. What will form? It's H here positive charge, or leaves out water, here else water and positive charge. If you compare that both intermediate, which one is more stable? This is very simple because this carbocation is stabilized by back bonding of lone pair of oxygen. So this is more stable. That's why this reaction goes to this pathway, not this. So now let here this intermediate is present, our alcohol is also present, R dash. This oxygen will attack on that carbon, and what will form? C double bond O, R dash, here H position. This proton will leave out, minus H plus. So what will form? OR dash. This is the very simple and easy mechanism of that reaction. Now let's come to the some important question based on that reaction. Before the question, first we will see some similar type of reaction, that is formation of esterification. This is the one of the method, the formation of ester. Let's see another method. Here any leaving group like chlorine, bromine, I am simply writing X is equal to halogen plus HOR dash, and here will also form OR dash, and formation of HX, that is halogen acid. But here halogen acid is present, therefore again hydrolysis of that reaction will be formed. So here pyridine is used. because this pyridine consume that acid. So what is formed here is that pyridinium salt. Sorry, here N, here X. This pyridinium will be salt and this acidic medium is neutralized, so this is stable. Now again one is that anhydride plus OH R dash. Simply from here remove that acidic acid group. So what will form? Let's see here, R C double bond O R dash. How this will be formed? That let's say I am writing here anhydride. Both are similar, therefore alcohol can attack any carbon. I am attacking here, so this bond will open, comes back, and this bond will go back. So what will form is that R C double bond O R, here H positive charge on that carbon, plus second one is R C double bond O minus. So this O minus will take that proton and remove out. This is the carboxylic acid, and one of this I am writing here. Let's see, R C double bond O R dash plus R C double bond OH. Now this is the one of the method to formation of ester also, which is involved in esterification reaction. Now let's come to one of the most important thing in that reaction is that our ester is the product. We got the product, but one thing is that this O comes from alcohol or is as it is of acid. This is the big question, but this can be easily solved by substituting one of the oxygen of alcohol by its isotope, let O18. That I am writing here is that, let's suppose this is our acid and our alcohol is, oxygen of alcohol is substituted by its isotope, which has atomic mass number is 18. So if we react it, after product formation we can easily find that this oxygen either comes to ester group or bioproduct water. So what will form is that, if you see in mechanism above, let's see here, this OH group is protonated and water removes out and carbocation form. After that what happening that this alcohol will attack, and this is the oxygen from alcohol. So this will O and this is 18 plus water. So due to substitution of isotope we can easily find out that in the ester oxygen comes from which molecule, alcohol or acid. So by indicating the oxygen we can easily solve that Curie problem. So this is the one of the very basic and simple reaction. Please remember that if acid is there, then acidic medium simply is there. But if acyl group, we can say acyl group, here halogen group is attached, then remember that pyridine is used here to stop the reversible reaction. And one of the esterification reaction is anhydride, we can also use. So this is the enough for this reaction. Now we will see the next reaction, that is Itard reaction, in the next video. Thank you guys.